right, so I got a question from a Cal 1 student. He's asking about the absolute extrema of 2 secant x. So we have, we're looking for absolute extrema of 2 secant x. And they're giving us a domain of negative pi over 6 to pi over 3. So the domain is negative pi over 6 to pi over 3. So a very powerful tool in mathematics in general is graphing things. Okay, so if you can graph something, you have a picture of it. All right, so it's very easy to see things, and it's very easy to explain things to other people by just showing them the picture. So let's try to graph this thing. So secant x, this is 1 over cosine x. Okay, so cosine x looks like this. I know the graph of cosine x, right? It has a maximum here at 1, the minimum here is negative 1. Now, since secant x is 1 over cosine x, anywhere cosine x is 0, secant x is going to have a vertical asymptote. So secant x is going to have a vertical asymptote here. It's going to have a vertical asymptote here. Okay? And here. Now we know that the period of the cosine function is 2 pi. So this is going to be 2 pi. So this must be pi. So this must be pi over 2, 3 pi over 2, 4 pi over 2, right? So this is going to be negative pi over 2. So this is what we're looking at, okay? And here we're between negative pi over 6, which would be about here, okay? So this is going to be negative pi over 6. And pi over 3, which is, let's say about here, okay? So this is about pi over 3. So secant x in this domain, okay, secant x is going to look like this. So that's secant x. This is cosine x, that's secant x. Now we have 2 secant x, okay, so it's going to take this graph and multiply it by 2. Well, here the value of the graph is 1, right? If I multiply that by 2, I get 2. Okay. If I have something that's increasing without bound and I multiply it by 2, it's still increasing without bound. So this graph is going to look something like that, okay? Now, you don't have to go through this procedure to construct these things, of course. You could just memorize these graphs, all right? But there it is. So these are not the graphs we need. That's cosine and secant and all that stuff. Okay, and so this is actually what we're looking at. This is our domain, right in here. Since that's our domain, we really don't have to distract ourselves with other things, okay? This is actually what we've got. So we're looking for absolute extrema, and with this picture, you know, it's pretty obvious that there's a maximum of extrema at 0, and it's a minimum. So that's a quick, easy way to do this with graphing.